Now we're going to add the two pieces of information that we used before in finding a missing side and finding a missing angle to find all the missing parts of a triangle. Okay, so now we're going to have to use a little bit more because it doesn't tell us exactly which process we're going to be using, so you have to do both of them. Okay, so solving the triangle. So here I have to find z, I have to find x, and I have to find, oh no, we have 15 and I have 40, and obviously the 90. And I need the y, that's the other one, the 90. So when we're solving the triangle, pick one first. So it doesn't matter which one I pick. Let's think about z first, okay? There's two ways that you could get z. Z you could find with previous pieces of information that you already know, or you could use trig to find it. So since this is 40 and this is 90, z is going to be 90 minus 40, because 180 minus 90 means that you have 90 left over, so these two have to be complementary. So 90 minus 40 is going to be z, so z is 50. The other way that I could find it is I could find a side first, and then once I have another one of the sides, I could do like we did the day before and find this one. So I'll show you that after we get another side. So let's pick x first. So when I'm finding x, I want to know what I have and what I want. So I'm going to use the 40 that I already have, so I'm going to label my triangle according to the angle of 40. It's very important that you remember that part because you have two angles that you could work from in this case. So the hypotenuse is across from the 90-degree angle, across from 40 is opposite, and next to it is adjacent. Okay? So if I want to find x, I have the adjacent, and I want the opposite. Okay? So opposite and adjacent goes with tangent. So I'm going to set it up as tangent of, notice I have the angle, so I'm going to put 40 next to the tangent, equals the opposite, which is x, over the adjacent, which is 15. So to get the x by itself, I have to get rid of the dividing by 15, so I'm going to multiply by 15. So I have 15 tangent of 40 equals x. So in your calculator, make sure you check the mode. You have 15 tangent of 40. So I have 12.57 when I round, or 59, sorry, I went down. So x is 12.59. Okay. Now, here, the other way that you could find z, now that I have a side, is I could have done z is from z, this would be the opposite, and this would be the adjacent. So if I wanted to find z, I would relabel my triangle according to the angle of z. So I would set it up with opposite and adjacent as tangent. So I would do tangent of z equals opposite, which is 15, over adjacent, which is x. So to get the x by itself, I multiply both sides by x. So now, wait, why do I have two variables? Oh, because we didn't, I didn't plug in x. So x is 12.59. That was the one that I had that I forgot to label. So let's try again. So, sorry. So I have 15 over 12.59. So now I'm going to do 15 divided by 12.59. So to find the angle, I'm going to do second tangent, or the inverse tangent, of 15 divided by 12.59. So notice in my calculator I have the long decimal version. You can use the answer that you have already. So if I do second tangent and then I do 15s on top, so 15, and I can divide by, and you can hit second and then your negative sign down here, which says A and S above it. So it's going to use my previous answer, so I'm not going to get any kind of rounding error. So if I do that, notice I get 50 degrees. So you could have found this either way. I showed you both ways. You only need to use one of them. Okay? Then we have our last one that's missing, which is y. So if we want to find y, okay, I'm going to use 40 because that's what we originally went from, the one that you're originally given. I kind of like to use the angle that we originally have. So I have for y, I have the opposite still. No, not the opposite, the adjacent. because we're looking at the 40. So I have the adjacent of 15, and I want the hypotenuse. So adjacent and hypotenuse goes with cosine. So cosine of the angle of 40, which I have, equals adjacent, which is 15, over the hypotenuse, which is y. So to get the y by itself, I have to put it on the top. So that's our first step. So I multiply both sides by y. Now, to get the y by itself, I have to divide by cosine of 40. So y is, 40, I dropped a 0. 15, 15, I already forgot, divided by cosine of 40. So I get 19.581. Now, just to remind you, since I already had the x, the side x, and the side of 15, I could have used the Pythagorean Theorem. So I could have set it up. I'm not going to show you how to finish solving, but I could have used 12.59 squared plus 15 squared to get y squared. So you could have used the Pythagorean Theorem. So there's lots of options when you're solving for the entire triangle that you can use. Okay, let's try one more. So we'll go the easy route on this one so that we can be quick. Okay? So first of all, to find z is going to be 90 minus 32. So if you do 90 minus 32, you get 58. Okay? So now, if I want to find, let's do x first again. It doesn't matter if I find x, y, or z first. They're comparable. If I wanted to find z using trigonometry as opposed to just using the idea that the sum of the angles in a triangle are 180, then I would have to find another side first. But other than that, it doesn't matter. So if I want to find x, I'm going to label according to 32. So 32, this is opposite, this is adjacent, this is hypotenuse. Now I could have labeled it according to 58. The reason I like to use the original triangle or the original angle is if this happens to be any kind of decimal, this can be a remainder one and it can get longer. They don't usually do those in geometry. They usually give you nicer numbers, but you can experience it later. So I like to use the one that's just as simple as we can get. So find x. So I have the information of the hypotenuse and I want the opposite. So opposite and hypotenuse is sine. So I do sine of 32 degrees, because that's the angle I label it from, equals opposite, which is x, over hypotenuse, which is 20. So I multiply both sides by 20. So I have 20 sine 32 equals x. So in my calculator, I do 20 sine 32, oops, not plus, delete, equals x. So 10.6, because you round the 9 up, so that gives it to a 10, and that moves that to a 6, so 10.6. Oops. Okay. Now I need to find y. So I found z, and I found x. Now I need one more. So if I find y is adjacent, and I have the hypotenuse still. Now notice I could use the x, but notice we had a long number here, so if you rounded to 10.6 on your y value, if you used this as a rounded 10.6, then this y value would be rounded. We call that a rounding error. So I try and avoid using things that are rounded from my calculator, if at all possible. If not, then I use the second answer button that I was showing you about a little bit earlier so that I can be precise as possible. Okay, so if I want to find y, we have adjacent over hypotenuse, so that's cosine of 32 degrees equals adjacent, which is y, over hypotenuse, which is 20. So once again, to get the y by itself, I multiply by 20 on both sides. So I have 20 cosine 32, which equals y. So I use my calculator. 20 cosine 32 gives me 16.96. Now I could have used the Pythagorean Theorem to get this as well. It's probably 6's as to which one is more lengthy. So, your choice. Okay, but that's how you find all the missing parts of a triangle. And the instructions, remember, again, are to solve the triangle. That gives you all the parts. They may have variables there for you. They may not have variables there for you on the triangle. So that's something important to remember. So make sure that you label it according to which angle. Remember which angle that you're using. And then find all the pieces of information. So the two missing sides, and the missing angle, or whatever else, whatever other option you are given. This is Square Rooter signing off.